Before diving into the world of reactive paradigm, let's understand what's a paradigm. A paradigm is a concept or a pattern in which certain things work. Basically, a set of things which follow the same pattern. A paradigm can also be termed as a method to solve problem or do so in a certain way. For example, a set of bricks can be transferred from the basement to the first floor via two methods. These are known as paradigms. For example, the worker can throw the bricks at a certain rate and the other person can catch it, or he can load the bricks onto a certain roller, which with the help of a crane can be moved to the first floor. So these two are different work patterns by which the bricks are transferred from the lower to the upper layer. So these are known as paradigms or patterns in which a particular task is being done. So in programming, we have certain paradigms. Let us see one by one, especially the reactive programming paradigm. There are certain number of programming paradigms, especially we would have worked with the OOPS pattern, the functional programming, and the event-driven programming, which is of the trend today. And with OOPS, we would have certainly worked with Java, C++, and many other programming languages that follows the OOPS pattern, and the functional programming, which is the heart of programming languages these days, and we certainly do love coding in a functional way, while the event-driven programming, which is the hot topic of the day, and we will be diving deep into that today. Okay, of all the list, there is no reactive programming, right? But it stands in between them. So where exactly do the reactive programming stands? A small example from this flowchart, wherein an event is fired from the user via an app. Either it could be a button click or a mouse hover or certain other things. The event is then passed to the event handler, which works internally. It moves the data to the actual internal logic where it would be handled the actual working. The flow goes in bidirection. The user is allowed to work on certain other features which the application has to offer. The user is not blocked until the response comes from the event. Whereas the event which is triggered gets its work done and then it notifies the user, either it could be via notification or the work is done in the backend, and when the user goes to the page, it is received. So this is how the event-driven pattern works. It is a non-blocking type and the user has a seamless experience. Before diving deeper, we will look into the differences between synchronous and asynchronous programming. First, take the example of a restaurant in which the user orders a food, he sits on the table and he is logged in till the food arrives. The food has to be prepared by the system, which has a certain time. Until then, the user is locked in the system, he cannot leave, and he can leave only when he is done with his food, or he can take a parcel, yet he is still inside the system. This is a common example for asynchronous programming, wherein the user is blocked until a certain process is done and the results are delivered. Now the second one, which is the asynchronous, wherein the user sits at his home, at his comfort, he takes the app, he orders food, the food is then prepared by the system, but the user is not inside the system. The system prepares the food, it then reaches the user can freely roam in other systems wherever he wants. He can then come when he is notified the food is reaching him, and then he can collect the food. This is a classic example of how the asynchronous way of working is done. Some common examples: Swiggy, Zomato, Rapido, wherein we order something or we book a cab. We'll just keep the app left for some time. Whenever the process is done, the end product, for example, the food in case of Swiggy or Zomato, or else a cab in terms of Rapido, when it arrives, it then notifies us to move towards the result and then we can achieve their product. In case of a booking app, for example, an IRCTC or Redbus or a movie booking app, wherein the flow is straight. We go step by step to book their tickets and then the ticket is received by us. There is no asynchronous operation in this, whereas to receive a product of the prior, we need an asynchronous approach. So this is how we can classify applications and their end products synchronously or asynchronously. This particular slide represents how certain programming languages handle their asynchronous operations. With JS, we have a single thread running, and it has its most elegant way of handling the asynchronous way of operation. With Java, we have the latest RX Java, Project Reactor. These are not new. These have established over years. Yet, these are still new to the world. And with Python, we have RxPy, and with Kotlin, we have the Reactor Kotlin or the Kotlin coroutines, which help in achieving the asynchronous operation. What are the benefits of a reactive approach? If we do not follow the event-driven approach, we will have to increase the resources, which will make the application to be non-blocking to the end user. Else, the user will feel the system is lagging. And for an enhanced responsiveness, we should write a non-blocking code which creates more responsiveness and a faster user experience. And in terms of the system design, the system should perform tasks whenever it is necessary, and it should not block the user unnecessarily for the synchronization purpose alone. To start off things for the reactive programming, I'm taking the reactive string, which has this event-driven approach. How we are going to establish things with Java, we will be seeing in detail in the upcoming things.